Hello everybody, my name is Aaron, and welcome to Major History. Today, we're going to be going over the origins of humanity, but firstly, touching on the origin of life as a whole, and discussing humanoids, and their first appearances on Earth. Firstly, though, as a general introduction to world civilization as a course that I am taking, it's important that we discuss the three sources of information for civilizations as a whole, which are archaeology, mythology, and linguistics. And it's important that we discuss these just as a general introduction to the topic of world civilization. So, archaeology is the study of humanity's history through physical evidence. And these physical evidence can be things like arrowheads, pottery, skeletal remains of humans. And all of these things can discover and determine the penultimate story, sorry, that is history. And for mythology, you might be shaking your head as to, especially if you're non-religious, like, oh, what place does religion or mythology have in history? And my answer is actually quite a bit, because for mythology, it actually gives us a glimpse into the psychology and ethics of a certain society. So the stories they tell through word of mouth, orally, over hundreds of years to tell their children how to behave and how to act. And this is present, this is omnipresent in the stories of King Arthur and the Knights of the Round Table, from the Greek myths of Zeus in Greece, to the Sumerians and the Indus River Valley civilizations from far before these two civilizations appear. We see mythology as the grounds for morals and ethics throughout these societies. And then there's linguistics. And linguistics is interesting, at least to me, because before genetics, we use linguistics to determine origins of certain groups of people. Using similarities and differences between each language paints a picture of how humans migrated from very early on. And this is especially evident with Proto-Indo-European rooted languages, which you could see here. We all started with a language called Proto-Indo-European, which moved on and split into separate regions, and it was actually, uh, not easy, but it allowed us to discover over time how languages evolved. And here we have the Romance languages: Romanian, Catalan, Spanish, Portuguese, uh, Italian, all of these languages. Sicilian, I didn't know that was a different language. It must be a different dialect or something. But yeah, linguistics is also very important for determining origins and migration patterns. So, to begin now on what the actual content is this week, we're going to be diving into the origins of the universe, the creation of Earth, and the origins of life as a whole. So, firstly, the Big Frickin' Bang, people. So, firstly, the Big Bang theory is the theory that postulates the beginning of the universe, or the beginning of existence as we know it. It's also important to note, I think, what a scientific theory actually is. Okay, because I feel like a lot of people will discredit scientific theories, saying they're just theories, they're just guesses, they're just something someone made up. But scientific theories are actually based on evidence, but cannot be proven without a shadow of a doubt, based solely on observation alone. This means that some theories, like the Big Bang or the theory of gravity, are so grand in scale that there is no possible way for them to be written into scientific fact, no matter how much evidence there is to suggest it. In the case of the Big Bang, scientists have observed, using the Hubble telescope, that all celestial bodies, meaning all galaxies and stars, are moving in a similar direction, almost as if away from a central point. And the theory that comes from this is that everything began from an infinitesimally small point in space, and for whatever reason, there was a supermassive explosion from this point that created all matter. The building blocks for everything in the universe. And other evidence to suggest this is that we've also observed cosmic background radiation, which scientists believe to be the leftover glow from the Big Bang at the far reaches of the universe, the end and the edge of the universe itself. We've observed this fairly recently, actually. So billions of years pass after the Big Bang, and celestial bodies are starting to form, creating hubs of matter in the form of galaxies and solar systems within those galaxies. Most importantly, our home, Earth, was formed 4.6 billion years ago. And, of course, life didn't immediately rise to the surface. As you can see here in this photo, the Earth was actually a hostile environment in its humble beginnings. Everything was incredibly hot, and meteors and asteroids were falling from space onto Earth's surface. Eventually, though, the Earth cooled down, allowing vapors to rain from its atmosphere, creating bodies of water on the planet's surface. And then we move on to the origin of life. After water was present, for whatever reason, Earth's first life began to form, whether it was abiogenesis or it was from something from the cosmos raining down onto Earth and bringing life here. We have no idea, and we have no way of knowing at any point in the future. But the first prokaryotes formed around 3.5 billion years ago, just a billion years after the Earth was formed fully. Eventually, though, these prokaryotes were single-celled organisms without a nucleus. But eventually, they would become more complex. They would build the nucleus. They would build organelles and everything such as this, and become eukaryotes. And then they would form together to be multicellular, and then multicellular, and so on and so on and so on until the Cambrian explosion 575 million years ago. So it takes 3 billion years for this to happen, by the way. 3 billion years. There's people out there that you think that they have like 200 times that amount in capital. But, this is actually a lot of money. Sorry, my fault. A lot of time. But it's not until a while later that the Cambrian explosion happens, and suddenly there are multiple large species of complex life on the ocean floor. And eventually, I know I'm covering this very fast, but there are multiple different species on Earth. And to understand evolution just like a little bit more, we need to discuss taxonomy, I think. So taxonomy, in a broad definition, is the organization of species by labeling them based on physical features. So in this tree here, we can see that vertebrae is the first defining characteristic of the animals on this list, of the categories of animals on this list. And then they have bony skeletons, and that only applies to ray-finned fish, amphibians, primates, rodents, crocodiles, and dinosaurs and birds. And then the 4 limbs only applies to these ones right here, and then amniotic eggs applies to all of these, but they split off in that these have hair, and these have 2 postorbital fenestrae. So that's just how we categorize species, and this all leads to the common ancestor theory, which is basically what we just discussed, is that all species come from a certain point, that we all share a common ancestor. So at one point there was a species that formed vertebrae, and then other pressures were placed on them that made them either not form any new characteristics or allowed them to form more characteristics and split off even further and further and further and further. And obviously there are a lot more differences in here. It's not just these things that separate them. Like this thing is slimy, this thing is hairy, this thing is also slimy, but not in the same way as this kind of slimy. It's different because this is the most basic representation of evolution that we can have. And then we get to the point where humans exist, and people discredit the notion of humans being related to apes because, they will often say, and I've heard this from even my own grandfather, if humans come from monkeys, why are there still monkeys? And, this question comes from a place of ignorance, and I'll happily answer it here. Humans do not come from monkeys. Monkeys are actually these guys right here. There's prosimians here. But these are all primates. This whole tree here is primates. But then we're further categorized into things like prosimians, monkeys, apes, and then subcategorized into certain groups like New World monkeys, Old World monkeys, great apes. And great apes are actually what we are a part of. Apes are not monkeys, but all monkeys and apes are primates. Just want to get that out of the way. So we share a common ancestor with chimpanzees, meaning we're cousins, but we're obviously not first cousins with a chimpanzee. Obviously, quite a bit a while ago, we shared one common ancestor, and the rest is history or prehistory or pre-prehistory. Um, so we did not come from monkeys or apes. We are apes. We are great apes. And monkeys are just a completely different thing. So that's just another thing. Anyway, eventually, the first mammals exist around 60 million years ago. And mammals are basically defined by the fact that they have hair and mammary glands. Mammary glands, what are they? They are the glands that produce milk to feed their offspring. So we give more or less live birth, and uh, with the exception of monotremes like platypus and echidnas. Um, but we give live birth, and we allow our little babies to nurse. And for the most part, these creatures are omnivorous or insectivorous or herbivorous. So they have a wide variety of diet, meaning that they can form multiple different species depending um, on their preference or whatever, based on the given situation, based on social pressures. Let's say there's not enough large animals to eat or something. Their jaws will form a different way because they're eating so many insects, or it'll allow different mutations to become beneficial based on different things. Okay, next is the first humanoid or human-like species to arrive in Africa around 7 million years ago. Not too long ago. I know people that have 100 times that in capital and property. But anyway, Sahelanthropus is the first known human ancestor. And you can see here that they're quite different. This is obviously a computer generation of what these creatures look like. They don't exist today, they're extinct. They existed a long time ago, but now they do not. And you can see that the skull is not too dissimilar. They have a large brow ridge, in their brain holder thing is not that large compared to ours today. But as we move on, you'll see that cranium actually become bigger and bigger and bigger. And note the teeth here; they look quite different from a human. Next is Ardipithecus, which appeared around 4.5 million years ago. And you can see here the brain is starting to get bigger, and you can see that these bones and these teeth are starting to become more reminiscent of life, of humans, sorry. And more computer generation. So the brains are getting bigger over time, and you can see this with Australopithecus africanus as well. And it's at this point that Australopithecus is actually spreading more throughout Africa. They're becoming less localized. And I don't think that this picture is incredibly accurate, but I really like the expression on his face. It kind of goes hard. I really liked this image, and I felt like I needed to put it in. Anyway, you can see the brain cavity getting bigger and bigger and bigger and bigger over time, and this guy's getting smilier and smilier, and he's happy. And then we move on to our first major change in Homo habilis. And Homo habilis is the first species that we know of that is able to use tools. albeit they are crude tools. They are just rocks, but we have evidence to suggest that this species actually formed these rocks into specific shapes to perform specific tasks, like cutting into flesh a little bit better. So there's that with Homo habilis. And then we move on to Homo erectus. And at this point, we are erect. We are standing straight up. We are no longer dragging our knuckles along the floor. We are standing straight up. I feel like I've seen this guy before. I feel like I've seen him. Anyway, Homo erectus arrives around 1.9 million years ago to 800,000 years ago. And it's at this point that we humanoids discover fire and how to use it, which means that we are able to cultivate it for our own means, and we're able to survive harsher temperatures and start to migrate north. And we are also cooking our food at this point, which means that stronger jawbones are not required for consumption, which means that our teeth here are not as specialized for chomping through raw meat and stuff like that. So there's that, and it's at this point that we're starting to migrate into Europe, into Eurasia, and parts of Southeast Asia as well. And next, and it's actually at this point that I believe that Neanderthals and Homo sapiens split. And then there's this next one. I don't know if you recognize this guy, but Homo sapiens arrive around 200,000 years ago in East Africa. And it's Homo sapiens that evolved to have a neocortex. And the neocortex is important because it allows us to have logic and reasoning, to ask questions like why or how. And it's actually just, basic curiosity coming from the first peoples. And you can see here their migration pattern coming from 200,000 years ago from Africa, moving into Eurasia, then Europe, then Northern Asia, Southeast Asia, and the Americas, and all of these through the Bering Strait Bridge that was there in the last ice age. And so 200,000 years ago, we did not have the hugest population. So all of us are sort of related, and it's interesting to note that all men and all women can trace themselves back to a singular ancestor. For women, it's 200,000 years ago using mitochondrial DNA. You inherit your mitochondrial DNA from your mother, and if you are a woman, you can trace your own mitochondrial DNA really far backwards, basically infinitely backwards, to around 200,000 years ago, in which all women share at least a little bit of DNA in their mitochondria. For men, you can trace back your Y chromosome all the way back to 100,000 years ago, so less than women. We are more related than women. All men are more related than women in this way. So all people are related. This is all people, whether you're Asian, whether you're black, whether you're white, whether you're indigenous American. We are all genetically related. Race is a social construct. I just want to point that out there. And so the next slide here that I have is what happened to the Neanderthals. So there's three theories for this. There's the regional continuity model, which basically suggests that both races continue to live on in separate regions. So they just, they're different races. But that doesn't make sense from what we learned here, in which all humans are related genetically. So that doesn't make total sense if we remain separate. But, you could also say with the complete replacement theory that the Neanderthals, they just died out, and the Homo sapiens are just all that remains. But there's actually DNA evidence to suggest that scientists have found that humans and Neanderthals actually share some DNA. So modern humans and Neanderthals actually share some DNA. So Neanderthals never truly went extinct. I think the best explanation is the partial replacement theory, which suggests interbreeding between Neanderthals and Homo sapiens, and eventually leading to the merging of species and the decline of the Neanderthals as a species, as a separate species. So we basically have Neanderthals and Homo sapiens in our DNA today. At least some. So I think it's the case that in Africa some Homo sapiens were made uncontacted by Neanderthals, so they never interbred. So I think that's what happened there. But I don't know. This here was my first world civilization lecture based on my notes from school. I'm currently a history major, and hence the name of this channel. And I think that if you want to see more of stuff like this, see the next lecture, you should subscribe, hit the bell to be notified, and you know what? If you like the video, it would make me happy. It would help me out a lot. And I think that you should leave a comment down below, telling me what your thoughts are. How do you think the Neanderthals went away? And what are your thoughts on everything here today? I'll try to debate you in the comments if need be. So, basically, I'm happy you watched this video, and I'll see you in the next one. Alright, bye-bye.